Lesson 2.3, Reflections. The goal today is to understand how reflection transformations work. Alright, so like we've been kind of discovering with SketchUp, that a reflection is just a type of transformation where a figure just gets flipped, and it's reflected or flipped in a line called the line of reflection. So down below we have an example. If the blue pentagon here is my original figure or my pre-image, this line denotes the line of reflection. It's kind of like a mirror, where on the other side or in the mirror, I see the exact same shape, but it's the mirror image of the original. Here's an example of a reflection. I've got my points, A, B, and C, which, if I join them together, are going to make a triangle. And what I'm going to do is I'm going to reflect this triangle. I'm going to make the mirror image of it over some line of reflection. And in this case, I think what we're going to do, just to show this example first, is that we're going to make the x-axis the line of reflection. So in other words, you have to imagine, even though there's already a line drawn here, that the line itself for our line of reflection is on the x-axis itself. So the x-axis is acting like a mirror. So if I want to reflect A, basically what I want to do is I want to go down to the line of reflection, and then I want to go that many spaces, 1, 2, 3 spaces, in the opposite direction. And so we would call this A prime. If I do it with C, notice how C is 1 unit above the line of reflection, so I want to go 1 line below, 1 unit below the line of reflection, and that's going to be C prime. And then this sometimes happens as well, which is that in this case, B is on the line of reflection itself, so it really doesn't go anywhere. It's 0 units away from the line of reflection, so B and B prime are the same thing. Now, if I've done this right, and I join together my points, what I should get is a congruent triangle, but it's just the mirror image version of the original. All right, so that's reflecting over the x-axis. Now you can imagine the y-axis is much the same thing then. Let's say I take this problem, and again, another triangle. And the only difference is where I'm putting the mirror, where I'm putting that line of reflection. So in this case, what has changed is we're going to make the y-axis the line of reflection. So if you can imagine A here, well, A is 1, 2, 3, 4, 5 units away from our mirror, our line of reflection. So I just want to go in the opposite direction, 1, 2, 3, 4, 5 spaces. And this would be A prime. All right, B, same thing. B is 2 spaces away from our mirror. So on the other side of the mirror, I'm going to put B prime. Now, this is where sometimes it gets a little tricky, and that's why I included this example, is that you'll notice how the other side of the triangle is already on the opposite side of the mirror. Okay, well, you do it no differently, though. Well, C is 2 spaces away on this side of the line of reflection, so I want to go 2 spaces in the opposite direction, and that's where C prime will go. Okay, and it always gets a little confusing when your line of reflection, your mirror, is within the object that you're trying to reflect. Okay, but once again, if you've done it right and you join all your points up, you should get the mirror image version of the original, and it should be congruent to the original as well. All right, so that's reflection. Now, most of the work you're going to do today is either going to have you do this, where x-axis is the line of reflection, or the y-axis, like this one. But in a future class, you may take it further, so I thought you might want to see this, where what we're going to do here is I'm going to once again reflect a triangle. I'm just picking a triangle because it's the easiest shape we can work with right now. But what I'm going to do is I'm going to make the line y equals -2 my line of reflection. In other words, if I go down 2 on the y-axis and I draw a line, well, then the reflection acts differently. So I'm not using the x-axis, so like for B here, B is 1 space away from the x-axis, but we're not paying attention to the x-axis because that's not our line of reflection. Our line of reflection is down here. So it's 1, 2, 3 spaces away from this point in our line of reflection. So I'm going to go 1, 2, 3 spaces the other direction, and that's B prime. A is 1, 2, 3, 4, 5, 6 spaces away, So down here I'll go 1, 2, 3, 4, 5, 6 spaces here. And then C is 1, 2, 3, 4 spaces away, so I'll go 1, 2, 3, 4 spaces this way. And so it's still the same thing. But just realize that what you're going to do in your work today versus what you're going to do in the future is that the line of reflection can be anywhere. In fact, you may get problems where the line of reflection is at a diagonal. Maybe this is our line of reflection, in which case you might have to reflect it something like this. Now, luckily, we don't have to get into this at this point, but we just so you know, I wanted you to realize that not everything is going to be like the work that we do, that we are going to take these ideas next year and expand on them and take them further. But for now, mainly, if you can do this example where I take an image and reflect it through the x-axis, or if I take an image like this and reflect it through the y-axis, you should be in good shape in terms of understanding this concept of reflection and lines of reflection.